Yeah, I'm curious now, Luca. How will you approach this, and how does your designing process look like?
Let's dive into it. Okay, so for me, Raj,
Hmm.
I always thought that the most important architecture characteristic in distributed system is modularity. Not only in distributed system, even when I was an engineer, I often refer to modularity with different terms, and there are different patterns to express that. But now that I lost all my hair several years ago, and I learned a bunch of things in the trenches, I always thought, for me, the modularity is becoming, let's say, a mantra every time I design everything, but not only in software, also in life. Even my home office is completely modular. I can remove stuff and add stuff in order to change the scene and the context based on what I want to achieve. That I think is an extremely cool characteristic that you can have in this world. So, but I want to first take a step back with you in order to explain, let's say, what I'm thinking when I'm designing in a modular fashion. So, when you think about modularity. I try to be as academic as possible here, and looking at the Cambridge Dictionary, you can see that basically is the conjunction of small parts that create a system. Like that is the perfect definition, if you think about that, of microservices, for instance. But then, more importantly, if the moment that you touch one element and that has
Hmm.
a cascade effect on inside the system, then basically you are in front of lack of modularity. That once again is basically the idea of coupling inside the system. So even if the Cambridge Dictionary that didn't refer to microservices, basically the perfect definition for it,
Hmm.
don't you think?
Yeah, 100%. So I think what you are enabling your customers is the agility and speed, because with modularity, they could easily replace or even update one of the components without impacting the other components. So to me, this makes the architecture very, very agile, right? And very, very fast moving.
Yeah. So and then I did let's say a step forward, right? And I started to ask myself, okay, how can I express modularity? This is how
Mhm.
usually we express modularity through code. Like, so we create our, depends from the language, the packages, modules, classes. We start to create interfaces. We start to have all these constructs that in reality behind the scene are completely modular, because I know that if I can inherit from another class, or I can have an interface, or I
Mhm.
can extend the class. I can do a lot of cool things. If you think about object-oriented programming or functional programming with composition, this modularity idea can be expressed in different ways. And very often, if you were talking about virtual machine, if I'm thinking about the history of software, we started with virtual machine and physical rack, where you can touch them, and there is like all the logic of a specific software, millions, if not more, of lines of code that basically are modular enough, and we try to do our best as a developer to make them, let's say, readable and useful for reaching what our business wants and the customer wants at the end. But slowly but steadily, we need to move from on-prem infrastructure into virtual machine, and then you
Mhm.
mentioned the containers and pods in Kubernetes. But there is also another way to express modularity that is not, let's say, merely dependent from the quality of your code, but can be also on infrastructure. Because when you move to the cloud, one thing that I always loved when I was customer of AWS is that I can compose stuff using the services and express certain intention using services. And in serverless, for instance, there are a lot of things that are abstracted for me, and I don't have to, let's say, rewrite and handling the governance behind sharing a library that then is used across all the teams, making sure that every team in the distributed system is using the latest version of the library, and all that, let's say, complex mechanisms that are
Mhm.
more on the people side, the organizational side, more on the technical side. And with serverless, instead, I have a lot of stuff that are built in. If you think about, for instance, step function, that is our orchestrator, you have retries, exponential backoff, a fantastic way to handle errors. So there are a lot of stuff that you can have out of the box that you don't even have to think, because there are hundreds of developers behind the scene that are
Mhm.
taking care for you about these characteristics.
No, I love it. So, question for you, Luca: do you approach this both for brownfield and greenfield projects, or this approach is mostly for one and not the other?
For both, to be honest, because the for me, the interesting part of this concept of modularity is that again, even in I don't know, even in a mainframe or a large code
Mhm,
base, there is always one portion that you can extract easily when you move into
mhm,
distributed system, and you need to think iteratively. It's very difficult in large software that you immediately have an idea of how everything is going to work. It's very difficult. And therefore I always like this lean mindset where
mhm,
you start to look and prepare a plan, not too loose but not even too detailed, and then you start to say, okay, so let's start to do the first step and let's see and go end to end. That's for me is very important things that I recommend every time. Go end to end, start to see not only how you extract but also how you route traffic, how you handle
mhm,
the deployment, how you design your CI/CD, all that character, how you set up the observability, that we cannot forget about that. All these characteristics are for me fundamental in order to achieve, let's say, the quality of the service that you're looking for. And then if it's brownfield, then nowadays there are a lot of if you want brownfield project, there is nothing wrong, by the way. Personal taste, I really love brownfield projects because you can learn a lot, you can unwind
right.
complex projects and problem for making them more streamlined and agile, as you mentioned before. So
Mhm.
yeah, definitely with both.
Okay, yeah, can't wait to see the architecture.
Yeah, so on serverless, very often people think that, oh yeah, I can only use event-driven architecture. I
Mm,
can only use a specific type of architecture for using serverless. But I want to demystify this once for all, because the reality is you can express yourself in exactly the same way that you can do with any other compute service. You can
mm,
use for creating integration patterns, data architectures. You can use microservices. You can use event-driven architecture. It's completely up to you what you need to express. Then there are, yes, some slightly different technical details that you need to be aware of, but that doesn't mean that you cannot create a synchronous API. So I want to show you this that happened to me literally last week. So when I design a serverless workload, I always think about the business requirements like you did, Raj, because I think
mhm,
is essential thinking about that. So for instance, in this one, I had this service that was just one service, not the entire service, but just one, that was a gift code service for an e-commerce. They have some third parties that generate, they have to interact with them because they are generating physical cards. So this customer had this need, and also they can generate an internal digital gift card. But then,
mhm,
moreover, they need to obviously notify the CRM, so the customer support, basically, that there is someone consume a specific gift code. They need to update the third-party company that the gift code was effectively consumed, and so on and so forth. Those are kind of requirements that usually you have when you design any service, right? In this case, we have those. But then the mental model for me is very important. So how can I move from there, from my business
mhm,
requirements, into something that is AWS, in this case with serverless? But I think always about the organization structure, how we are structured, because it's important to understand how broad is the, let's say, scope, how many teams are going to be involved. Because if I
mm,
have like 10 teams that are going to be involved in a feature, then I need to think about the communication that is quite key. And inside their bounded context, they can do whatever they want. So that for me is the first thing that I look into. The second thing is traffic pattern. Because the reality is, serverless, like any other service in AWS, has quotas that we need to be aware of. Therefore, if I have like a very spiky traffic, or I have, let's say, a surge, a very gentle
mhm,
surge of traffic, is a completely different way how you design your system. And that is another key characteristic that we need to take into account when we design stuff. Then obviously the SLA. Sometimes you have some APIs that requires to be at the microsecond response time, and maybe having less hops in the network helps to in order to return back the response very quickly. Then I think about the characteristics. So what do you need? It's like I don't know. You need to communicate service to service using HMAC instead of JWT tokens, or you need to use a multi-region approach or active passive. So all these kind of things for me are important to understand what I need to express. But the other thing that very often, and I think for serverless
mm,
is quite stress out on this case is understanding if you really need synchronous API, because vast majority of the time what I have seen, especially people that are teams that are starting at the beginning thinking about serverless, the reason very often everything's synchronous. I call this
Right.
service, I call that service, I call that service, but no one in the business requirement or architecture characteristics asks them to do it. And I don't know if it's the same for you, but when I was working
Mhm.
in a system that has a very spiky traffic, I tend to have as minimum as possible of synchronous communication and as much as possible of asynchronous communication, because then
Mhm.
I can really design without stressing out the system and all the cascade effect that could have across the entire distributed system.
Yeah, no, I agree. I think our initial response to any architecture is, yeah, we must make it synchronous. When I was a customer, that's how I would think. But if you think deeply, any system could be broken down into sync plus async, right? It's a misconception that everything needs to be sync.
I agree with you. I think very often, we don't challenge enough our
Right.
PMs and our tech leads to understand if it's doable. And when I did that, I always had great result.
Mhm.
And last but not least, there is something that we need to be aware on the context is the existing patterns, right? So you need also to
Mhm.
understand if someone else has some key requirements. Like I always have this idea in my mind when I was working with the security team. The security team
Mhm.
obviously has some strong requirements that you cannot avoid, and therefore those requirements needs to be taken into account when you are thinking what you need to express. So high level, the architecture that I was talking with the customer is something like that, right?
Mhm.
So I have a request that is coming from the e-commerce into the gift code service, and the gift code service has to communicate with the third-party system, with the user account, because we need to store a history of all the gift code that were redeemed by a specific user, and then the CRM for the customer support. So those are the three things. Now, the interesting part is here understanding what are the requirements, the real requirements here. Because yes, when I know that the gift code is available, then I know enough that probably if it takes 1 minute to arrive to the third party gift code system, no one will scream. And
Mhm.
similarly to the user account, yes, maybe you're not going to have at the microsecond the transaction on a database, but also if it's like 1 second, I struggle to see a user that is moving from redeeming a gift code immediately to the user account for seeing that. So there are certain things that you can, let's say, think asynchronously and embrace eventual consistency, because it's where really where distributed system shines. Okay, so when I have these, I started to map into, let's say, a bunch of several
Mhm.
services. Now, it might seem that there are a bazillion of things going here because there are way more icons than what you had in your diagrams, Raj. But the reality is very simple when you start to break down. So we have this part that is the front-facing
Mhm.
API that has a back office API that is needed for communicating with the third party system or with the admin that are generating gift code and storing inside database. And then the other part is that the redemption of the gift code, that in reality is just a lookup of a specific gift code that was inserted by the user, and make sure that that is available or usable in general based on the rules that you want to apply. And when you have done that, job done for this service. Everything else doesn't have to wait, and therefore
Mhm.
paying for this wait for knowing that happens. The moment that you capture the intention of the user, you can slowly but steadily move with other, let's say, patterns into notifying everyone. So, for instance, in order to move from the first part that is as simple as an API gateway and Lambda function and a DynamoDB table, we can use DynamoDB stream to capture the change when
Mhm.
the gift code is redeemed, and then use, for instance, the event bridge pipe to, let's say, transform these event from DynamoDB into event bridge, And that we will move into an event-driven architecture approach, because it's very likely that the other from this point onwards, there are other teams that needs to know this information, and potentially today there are 3, but tomorrow, who knows, maybe there are 25. We don't know. And therefore, from using an event-driven architecture, we can easily say from the producer, okay, I have redeemed this gift code, and this is the idea of the gift code, and potentially the idea of the user, depends who you need to notify to. And then based on the integration, you can have, for instance, different consumers that are designed differently. So for instance, we can leverage the third-party system in different ways. We can have a consumer that is a Lambda, takes the event and then transform in a way that the third-party system will understand, maybe calling an API, specific API, or you can directly use API destination. That is a feature from EventBridge that enables you to directly call, after you trigger an event, a specific API, and use authentication in order to make sure that you are entitled to do that. Or you can use for the CRM a queue, because it's an integration in this case. You know that 99% of the time when you deal with third-party system, they have, especially when they are multi-tenant, you have, let's say, some limits on the amount of calls that you have, and you don't want to be the noisy neighbor where you start to hit the third-party system, having a lot of throttling and causing more harm than benefit. So usually you put a nice queue in front of it, and then you drain this queue at your own will. And then for an internal communication between microservices, so different bounded context, where you can use, for instance, another consumer that is a Lambda that then will update a database or store in a queue, wherever it will be the thing. But as you can see here now, because I have different contexts and different teams that are dealing with different technology and different requirements, the area that for me is one of the key things when I'm thinking about serverless. Because very often, if everything is synchronous, the only way to communicate is in a synchronous fashion. But there are so many great ways to express that, and even make this architecture evolutionary. So taking an additional, for instance, part of the system could be like the data lake, and you want to send this event into the data lake. Potentially, you can plug another consumer on the event bridge, and then start to use that for capturing all the gift codes that are redeemed from different customer, playing some analysis on that. So as you can see, that, let's say, this modularity allows us to express ourselves very deeply, not only on the code side and how we structure encapsulation or, I don't know, a facade pattern or whatever it is, but we arrive to express the business requirements into services and then apply the code on top of it in a modular fashion. So modularity here for me is expressed at different level, from the code level inside the service to the infrastructure to the organization. And when it's matching, then it becomes very easily to change and swap things around without impacting the rest of the system.
No, I love this. And yes, your diagram do have way more icons, but your diagram looks way cooler than mine. More prettier, more colorful icons. Jokes aside, so yes, modularity, amazing way to achieve this. Also, when I look at these services, it automatically satisfies some of the other architectural design factors, such as high availability, right, cost optimized, because all these services I'm looking at, Event Bridge, Lambda, API Gateway, DynamoDB, by default they are deployed in more than one availability zone. They are all pay as you go. By default they have a secure posture, right? So those are some of the other advantages I see. Of course, this allows the teams to just plug out one of these blue box and replace it with something else without impacting any of the other components of the architecture. But in my mind, this is also adding some of the other inherent powerful features that you don't have to think and implement separately.
Totally. But to be honest, I believe that also in yours, we can find some of those characteristics. The only difference I would say is it's the amount of ownership that,
Yeah,
let's say, a team has on specific things that sometimes is what we call in AWS undifferentiating heavy lifting. Some
right.
stuff you can delegate to the cloud provider. Sometimes you want to own these things, and I believe it's very important to understand when owning a specific part of the system makes more sense, because generate a competitive advantage for the company. Because sometimes, it's not just for writing more code that means we are better developers. Sometimes
Right.
we need to play smarter and use the right approach for achieving the business requirements.
No, I love this. I think you said it correctly. You can achieve the same level of high availability, security, cost optimization. It's just how much or what you have to do from service to service, right? With Kubernetes, if you want to make it highly available, you have to adopt something called pod topology spread, right? Can you make it highly available? Yes. Do you have to own it? Yes. And sometimes making that makes more sense.
I think both approaches, as usual, as we said at the beginning, have their trade-off. But that's also the
Right.
beauty. Or if we understand really what are our intentions, and in both architecture, we started to from the business requirements,
Mhm.
moving into the architecture characteristics, and then finally cherry picking the right service for what we need to express, then we have a good chance that we make it right, despite we choose serverless or not.
Okay, so Luca, seems like we have two very, very powerful architectural options in our back pocket. We saw how you can design a system with Kubernetes. Now we are seeing how you can design something with serverless as well. So how do you select the approach?
But I think it depends is the right answer in this case, because there is one of my favorite architects is Neil Ford, and he's used to say you need to pick the least worst architecture that has basically the best trade-off that you can have for a specific context. And I think the idea of context is quite key here.
For me personally, of course, context and the customer requirements, there are a lot of requirements that come into play. And sometimes you combine both of these. I literally implemented a project where the messaging was done using EventBridge and SQS, but the business processing was done in Kubernetes. So that was a great project for me. We just got the blog approved, so hopefully we'll be able to share the name and how it was done. But I think that's the correct mindset. Like Andy Jassy said, right tool for the right job. Sometimes we just pigeonhole ourselves into one or the other. If you keep your mind open, work backward from the requirements and select whether it's a serverless or Kubernetes solution, combine them, and then you can achieve like a great architecture.
Absolutely, I think that is the best advice that we can give for our customers.
Excellent. Well, thank you, Luca, for brainstorming how to approach any architecture and map AWS services with me. It was a pleasure.
Yeah, thank you, and see you in the next meeting.